Hi Science2 kiddos. I'm going to walk you through in this video how to do the gravity visualized activity. You're going to need a few supplies for this. You'll need some kind of fabric, so if you've got a good sized dish towel, or this is just one of my running shirt, these work really well because they've kind of got an elastic material that might be good to use, but you could also use like cellophane if you have a cellophane in your kitchen. Cellophane wrap like that. You'll need some kind of attachment, so either binder clips, bigger ones than these, or you could even use like a shoelace or a belt or something like that that's going to hold the fabric onto the pot that you use. You need some kind of weight. Smaller is better, so things like batteries are pretty dense. Those are good to use. You've got paper weight, even just a rock from outside. Those will work well enough. If you've got like a scented candle, those are sometimes pretty heavy enough to make a difference. And you'll need some kind of ball, something that can rotate. And again, if you can find small ones, that's pretty good. I got these out of like a game set, like a board game kind of thing, so maybe look through those. You might actually have something like that, but if you don't, a tennis ball or a lacrosse ball or something like that will work fine as well. So kind of whatever you can find that's of that size, and you can make most things work. And then you'll need some kind of bowl. You could use anything from a pie pan to a cooking bowl to whatever you might have that just gives you that round frame that you can attach the fabric to. And I'll kind of show you a couple different ones that I made. So here's how this is going to work. Here is just one that I made. You can see that I've attached, again, this is just one of my like running shirts to a pot using these binder clips here. And the first thing to do, I think, is rather than using a weight, just use your hand. Press down in the middle with your finger, and you'll see if I put this little ball here, it just falls right to the center. So that's essentially Einstein's idea of gravity, that by pressing in the middle, I am simulating the bending of space-time, and any other object I add in there is immediately attracted to it. Now, as he does in the video, what happens if I throw it sideways? You'll see that you get a little bit of an orbit there. And your goal is to try to at least get one full circle. And it had kind of a nice elliptical orbit there for a second. Now, that gets a little harder if you're using something like a tennis ball, because I can't exactly rotate a tennis ball around my hand. And so if you've got a spoon or a knife or a fork, obviously be careful with this, but you can use that to press into the middle, right? And that gives you more distance than if you're using a larger projectile like a tennis ball. You should be able to still kind of get at least one cycle around to kind of simulate that rotation. And then if you want, then you can start putting masses in the middle. So what I typically do is use 2 batteries, or 3 batteries, whatever that's dense enough. And again, you can kind of see that they fall towards the middle there, and you can get a little bit of an orbit going with these. I think the batteries are a little bit of an awkward size, but again, you can use any kind of object. Honestly, sometimes it works too that if you've got numerous smaller satellites, you can just place them in the middle, and then you can get one to rotate around them. And you really have to kind of work on sending it parallel. Now, granted, this, I think that my setup here isn't working that well either. So just to show you a couple other different ones that I made. This is just a regular t-shirt put around a sort of pie pan. You can see I used a shoelace to tie it on. But it should work relatively well, or at least in the same way. That I'm able to send a projectile around somewhat. Let me see if I can use something like let me put a lemon in the middle of this one. That's still gonna, warp my space-time in this galaxy here, and then again I can probably still get at least one rotation around. This is a dish towel that I just literally attached using this is a kind of like hooking device you would use on your car to like tie your bike down or something like that, and I found that works pretty well. And this one was actually probably one of the better ones in terms of the rotation. Oop, I overshot there. But again, you can kind of get the orbit going around. This one actually works surprisingly well, I think. Part of the trick is getting that initial sideways launch to work. All right, last one I'll show you. If you're really in a bind and you can't get your, you can't find fabric or anything, this is just a pie pan with a little bit of cellophane in the middle of it. Let's try this one with the batteries, or actually, you know what? Let's use there's a stone I found outside. It's round, but should be able to get a little bit of rotation or orbit going there. So again, warping my space-time, and there's my object being gravitationally attracted, and then I can send it in an orbit around it. I get about at least one good circle. You can see that, or even more than that. And again, you don't have to use a mass in the middle. You can just get pressing with your finger or pressing with a knife or some other kind of utensil. I think those generate the best videos. So the only thing you're required to film is, again, you could either be pressing in the middle with a finger or using a weight. It doesn't matter to me, but show that you have something that is bending space-time in the middle, and that when you just let go of your satellite, it falls directly to it in the middle. That's sort of our gravitational attraction. And then get at least one full circle of orbit by sending it sideways, like that. That's all I need to see in the video. And, you know, if you want, it'd be good to explain what's going on. So here is the gravitational attraction due to the warping of space-time by that larger mass that's in the middle. And then here it is orbiting around because I have now got an equal measure of the gravitational force and that tangential velocity, but the orbit decays as it goes into the middle. All right, have fun, give it a try, post to Flipgrid. Thank you.